Hess law of constant heat summation. Hess law of constant heat summation. Hess law of constant heat summation states that the net heat evolved or absorbed in a chemical process is the same whether the reaction takes place in one or in several steps. Okay. We will discuss one example first. After that, we will come back to the definition once again. Then this law will be clear to you. We will discuss one example. Actually, many compounds can't be prepared in its pure form in pure form from its elements. Okay, when we are discussing this, first you need to remember the definitions of heat of formation, heat of combustion and heat of reaction. Especially heat of formation, many compounds cannot be prepared in pure form from its elements. That means you consider heat of formation of CO, that is C plus half O2 gives CO. Okay, C plus half O2 gives CO. You just consider this reaction. In this reaction, 1 mole of CO is forming from elements only, C and oxygen. This is a graphite form only here. So from its elements. So here you will have the change in enthalpy, which can be referred as a delta HF. Okay, but what we are saying is here heat of formation of CO cannot be measured directly. Why? We know whenever we are trying to prepare CO, along with the CO, some CO2 will also be formed. CO cannot be obtained in a pure form. So along with the CO can't be obtained. This example, if you understand clearly, that only is Hess law. CO can't be obtained in pure form. Along with the CO, CO2 will also form. CO2 will also be formed. Okay, because after CO is formed, again here oxygen is available now. Again it will react with oxygen, immediately CO2 will be formed. So it is difficult to prepare CO in pure form. Then when that is not possible, how can you measure delta HF of CO? So therefore it is not possible to measure delta HF of CO. It is not possible to measure delta HF of CO because CO cannot be prepared in a pure form. But what could be done is, but CO2 can be prepared in pure form, but because complete combustion. That means, but CO2 can be formed, that is C plus O2 gives CO2. Let it be equation 2. This could be carried out. 1 mole of CO2 we can obtain from its elements, complete combustion, and we can measure the values of delta HF also. I'll write the values. Next, another and CO can be taken and it can be oxidized to get CO2. This also could be done. This is another equation 3. Its delta HF is minus 94.045 minus 94.052 kilocalories. Okay, and here minus 67, delta HF equal to minus 67.636 kilocalories. Okay, so CO can't be prepared in its pure form. That is why delta HF cannot be measured directly. But what could be done is CO2 can be prepared in a pure form with this equation. So delta HF can be measured and its value is this much. And we can also do one more thing. CO can be taken and it can be converted to CO2. This also could be carried out and delta HF of this is so much. So these two are available. So now CO, since we can't measure CO, then now what we should do is by doing some manipulations over 2 and 3, we should prepare this equation. That is so what it is now? Equation 2 minus 3. If you write 2 minus 3 here, what happens? C plus O2. That is here C plus O2 minus half O2. Here half O2. Okay. CO2 gets cancelled. And here minus CO, no? 2 minus 3. That comes to the other side. That is CO. Okay. 2 minus 3 is nothing but what now? Is it equation 4, which is same as 1. Equation 1. By doing this manipulation, what? Equation 2 minus equation 3, we are getting this equation, which is the formation of CO. So now you must have understood. We don't find out, we don't measure heat of formation of CO, but we can calculate heat of formation of CO using equation 2 and equation 3. That means here 2 and 3 we are subtracting. Now we are subtracting 3 from 2. So in the same way, delta HF, last class we have discussed, if you are multiplying the entire equation with same coefficient, delta HF also must be multiplied. Like that, whatever the manipulations we do, the same manipulation we should do for the delta HF also. So now what is that? So if this is like, can we say delta HF of 3? Yeah, means third equation. Delta HF of 3, third equation. And this is delta HF of 2, means second equation here. Therefore, delta HF of CO is equal to delta HF of 3, delta HF of 2 minus delta HF of 3. 2 minus 3 we are doing to get this equation. So delta HF of 2 minus delta HF of 3 we need to do. So this is minus 94.052 minus of 67.636. So that value is minus 26,415 kilocalories. Okay. So this is heat of formation of CO. Okay. Now using this example we are discussing. So what is this example? Formation of CO. C plus half O2 gives CO. Actually we need to conduct this reaction and measure the change in enthalpy. That is heat of formation. But it is difficult to prepare CO in its pure form. So it is not possible to measure heat of formation of CO. In such cases, what to do? Without conducting this experiment, we can find out some other way. What is that some other way? Here, CO2 can be prepared using this equation and one more equation too. That is C plus O2 gives CO2. That also could be carried out, and both the reactions delta HF can be found out. So 2 minus 3 we get this. So simply by subtracting this heat of formations we are. So without preparing CO in the pure form, using CO2 preparation equations and their delta HF values, we are able to find out heat of formation of CO. Okay. So heat of formation of CO, whether CO is formed in one step, this is one step. This is one step. CO is forming in one step. C plus half O2 gives a CO2. CO is forming in one step. Or whether it is two steps are there. That is equation 2 one step, equation 3 one step, 2 minus 3 we are doing. So it is forming in several steps. 2 steps here. In some other problems, more steps. Okay. But the net change in this enthalpy is same. That is, now we will read out Hess law. It will be clear to you. Hess law of constant heat summation states that the net heat evolved or absorbed in a chemical process, that is this net heat evolved or absorbed in a chemical process, is the same whether the reaction takes place in one step, means either this way or in several steps, equations 2 and 3. So like this, this Hess law is useful. Therefore Hess law is useful. Hess law is useful to find out delta HF of compounds which can't be prepared in a pure form. Okay, which can't be prepared in a pure form. So that is Hess law. Means in the Hess law, a series of reactions will be given. So what we'll do in these problems, next class we'll solve problems using Hess law. So a series of reactions will be given with delta H values. Then do mathematical manipulations. Do some manipulations over those equations and then get final equation where the product is the component in question. It is the component in question. Okay, these are the steps to solve. One more step. So the same manipulation, do the above manipulation, same manipulation what we have done here to get this equation. Do the above manipulation. With the delta H values of every step of every reaction or the step. Okay, these are the steps to solve the problems using Hess law of constant heat summation. We'll solve the problems in the next class. Thank you.